Starting with this topic, multiple integrals, we shall take a look upon other concepts through which the concept of integration comes into play. So here we know the areas of these predefined curves, like the area of a square, the area of a rectangle, area of triangle, area of circle. We all know these areas. So the formulas are, we all know. It will be, area will be side square for a square, it will be length into breadth for a rectangle. For a triangle, it will be root over 3 by 4 side square, and for a circle it will be pi r square. We all know the areas of these predefined curves, the curves we already know, like we know how they will look. So but for areas for not predefined, the curves which are unknown to us, a function will be given, the graph will be provided maybe. So here we have function fx with a graph which is unknown for us, curve which is unknown for us, and here we have another graph for which we don't know the area enclosed by the function. So to find out this area, what we need to do? Here we need to apply integration. Let's take this limit as a and b, and this limit as again a and b. So what will be the area enclosed? The area enclosed for both of this graph will be integration of fx with respect to dx from a to b. So here comes the concept of integration. I'm not going in details for this concept because this we have learned much earlier. So I'm not going deep into this concept. And don't forget to remember or memorize all the integration formulas you have done till now, because they will be required, like it will be required to learn them and to memorize them, because at every step we required the formulas of integration. So here we now come to the concept of double integration. Previously we have done this type of integration, like fx dx, or this type, or fx dx from a to b. This integration we know, we call it as indefinite integral because the limits are not defined. But for this we call it definite integral because the limits here from a to b is defined. So we can say, so this we have done in the first semester, we all know. But in this semester we will focus on this concept that integration will depend on the number of variables. So let me write it down. So this is the main concept for multiple integrals. So integration depends on number of variables. As the number of variables sorry for this handwriting. As number of variables increases, number of integration, number of times we have to integrate will also increase. So like for two variables, if we have two variables, we need to integrate twice. For three variables, we have to integrate thrice. Like this concept depends. Okay, so I have divided the questions or the type of questions in three types. So here we have the type 1, where we have the question with constant limits. Okay, for example, like from C to D, from A to B, fx y dy dx. In this question, we see the limits are defined and they are constants. Like they does not depend on any variables like x here and y here. So it depends, the limits are constants here. So I have divided this as a type 1. For this type of question, you will see, like since dy is here, the limits are of y. The first limits are of y, and then dx is here, therefore the second limits are of x. So first we need to integrate dy here. When we integrate dy here, we always have to remember that for dy we need to take the limits of y only. We can't take the limits of x. We have to take the limits of y only. So this will proceed as, therefore we will do the integration of fx comma y with respect to dy. So this formula will become like this. We need to first integrate fx comma y with respect to dy. With respect to dy first and then with respect to dx. So this is the concept behind this. And if you say like in the question, if we have dx and dy here, like the order changes to dy dx, and these are the limits of y then, and these are the limits of x then. Because we have dy here, the limits will be always with of the y here. Here there will be the limits of y, because here we have dy, and then we have dx, therefore the limits here will be of the x. So here we will have a to b, like the previous one, integration over c to d f comma x comma y dy. We have to integrate with respect to dy first, then with respect to dx. So this is the basic type. We will move on to the second type. So here we are with the second type of questions we will get where the limits are variable. Here the limits can be in terms of x or in y. As we can see in this question, the limits are in terms of x, which is a variable here. Therefore, in this type we will identify by seeing the limits. So here the order of integration matters. The variable limit here, this one, we need to integrate with respect to this. So note this down that if the variable limit is in terms of x, then we need to integrate with respect to dy and vice versa. That is, if we have the limits in terms of y, we need to integrate with respect to dx. Why? Because if the limits are in terms of x, then the limit are actually of the limits of y. Therefore, we integrate with respect to dy here. And if the limits are in terms of y here, then the limits are actually of x. As this is the variable limits, so then we need to integrate with respect to dx. So this is the fundamental concept of variable limit. So write this note down that if the variable limits are in terms of x, then the limits are actually of y. Therefore, we integrate with respect to dy and vice versa. That is, if the limits are in terms of y, then the limits are actually of x. Therefore, we integrate with respect to dx. So now we move on to the question. This was the question given for this type. So now we will integrate with respect to y for this limit. We need to integrate the function with respect to the variable limit first. So let's do this. 0 to 1, 0 to 1. So we will integrate xy with respect to dy, variable limit x squared to x dx. Okay. Then if we integrate, it comes to be x y square by 2. Since we are integrating with respect to dy, therefore x we are considering as constant. Zero to 1, and here x square to x. Therefore, it will be equal to integration over 0 to 1 x into x square by 2 minus x to the power 4 by 2 dx into dx. Sorry, I will write this down afresh. So I'm writing down that as afresh. So here we x square by 2 minus x to the power 4 by 2 dx, and which will be equal to x to the power cube by 2 dx from 0 to 1 minus x to the power 5 by 2 dx, 5 x to the power 5 by 2 dx 0 to 1. So here it will be equal to x to the power 4 by 8 0 to 1, x to the power 6 by 12 0 to 1. So the answer will be like this: 1 by 12 equals to 3 minus 2 by 24 equals to 1 by 24. So here we solve this question of type 2. we are starting with the third type. The third type, in the third type, no limits will be given. So here we need to find out the limits. We have taken this example. Evaluate this integration over the positive quadrant of the circle x square plus y square equals to a square. Here we can see there is no limits provided in the double integration. So we need to find this limit by ourselves from this equation provided. So here we need to follow 4 basic steps, and I have written down this in the next slide. So here the 4 steps we need to follow. First, we need to trace the curve. Then we need to identify the region which we have to integrate. For that, we need to then find out the limits. And then finally, we need to integrate the given double integration. So here, we start with the first step. That is, we will trace the curve. So here, for tracing the curve, the equation is given x square plus y square equals to a square. This is the equation of a circle. The general equation of a circle is, we know. I'm writing down this in the next slide, okay. General equation is x minus 8 square plus y minus k whole square equals to r square. So here h comma k was a center and r will be the radius, okay. So by comparing with this general form, we can say that the given equation or the given circle, for the given circle, the center should be 0, 0 and radius is a. Okay. So now we have identified how this graph will look like. Now we need to plot this. So here I have plotted the graph. This is a circle of the equation x square plus y square equals to a square. And I have written down the points here, and this one. So now we come to the second step. Now we need to identify the region we need to integrate. So in the question given, we can see here, it was written over the positive quadrant. So now, which is a positive quadrant? This is a positive quadrant. This one. So this one is a positive quadrant. So we need to integrate this region. Okay. This region. So now we have identified the region. So the second step is also done. Now, third step and the most important step of these questions is to find the limits or extracting the limits. So in the third step, we need to extract this limit. So to extract the limits, we need to take strips. There are 2 ways to find out this limits. We can take horizontal strip and vertical strip. We need to take this strip and we can do it in 2 ways. That is by taking horizontal strip and vertical strip. For horizontal strip, the limits of the strip will be of x. For horizontal strip, the limits of the strip will be of x. And for vertical strip, the limits of the strip will be of y. So Now we will take both the strips. I'm just showing you first the horizontal strip. Here we have taken the horizontal strip. We can see horizontal strip we have taken this one. So now we will extract the limits from this graph. Okay, so extracting the limits of the strips here. So this will be a point and this will be a point for the horizontal strip. This will be the upper limit and this will be the this will be the lower limit and this will be the upper limit. Okay, since this is why will be this as lower limit, because we can see in this direction the value of x increases, so the lower limit will come first and then the upper limit will come. So in this way, this we need to find out this lower limit and upper limit. So here the lower limit will be 0, we can see, and since this point is touching the circle, so this x will be this lower limit x for the value limit of x, lower limit of x will be a square minus y square, as we can put that point in the equation of the circle, and so here the upper limit will be this. Okay, and now we need to integrate this horizontal strip over this region. So then the outer limit will be from here 0 to here a. We need to integrate over this region. So the limits of y will be from 0 to a. So let me write this down here in this slide. Okay, so the limits of x will be 0 to x equals to root over a square minus y square. Okay, and limits of y will be 0 to 0 to y equals to a. Okay, so now we will write down the limits in the integration here, dx dy. So first the limits for the strip will be 0 to root over a square minus y square, and then the limits of y from 0 to a. So this is for the horizontal strip. Now we will move on to the vertical strip here. So for the vertical strip, this is the vertical strip, this is the vertical strip, this is the vertical strip. So for this, similarly, we need to find out the upper and lower limit for the strip. Upper and lower limit for the strip, this here will be the lower limit, and here it will be the upper limit. Since in this direction the value of y increases, therefore this will be the lower limit and this will be the upper limit. Okay, so we need to find out this one. So lower limit, we can see it will be 0. It's touching this point of x-axis, so it is y equals to 0. Equation of x-axis is y equals to 0. So lower limit is 0 and upper limit will be, it is touching a circle here too, So upper limit will be root over a square minus x square. Okay, let me write it down afresh. It will be a square minus x square. So this one. So then we need to integrate this strip over this region, right? The limits of x will be here. X will be, we know, from this point 0 to this point a. So let me write this down in the next page. Limits of y will be y equals to 0 to y equals to root over a square minus x square, and limits of x will be 0 to x equals to a. So now we will be putting the limits in the double integration xy dx dy. So first the limits of the strip 0 to root over a square minus x square, and then the limits of x 0 to a. So finally we have done till this. This was a third step and the most important step. Now in the fourth step we need to integrate. So before that I would like to tell you something like this. Let's listen to this. So here we are first taking the strip here. Therefore we are writing the limits of the strip first, and then since we are integrating over this region, therefore we are writing the limits of this region, that is here from 0 to a, that is the limits of x here. So similarly the vertical strip in the horizontal strip we do like this only. We are taking the horizontal strip, so we are writing the limits of the horizontal strip first, and then since we are integrating over this region, therefore we are then writing the limits from 0 to a, that is the limits of y here. So now let's move on to the fourth step, that is the last step. Here we need to integrate. So I'm just integrating for the horizontal strip because it will be similar type. The integration will be of similar type for the horizontal and vertical strip. So I'm just integrating for the horizontal strip here from 0 to a, 0 to a square minus y square, y square. Okay, xy dx dy. So here 0 to a, 0 to root over a square minus y square. So xy dx dy. So the next line will be like this. Since we are integrating with respect to dx, y is considered constant, and x square by 2, 0 to root over a square minus y square, then dy. So here 0 to a, 0 to a, y into a square minus y square by 2 dy. In the next line we will have equals to a square y dy by 2, 0 to a minus 0 to a y cube dy by 2. So here we will have a square as constant, and then we will integrate y dy, that is y square by 2, 0 to a minus y to the power 4 by 8, 0 to a Then we have a to the power 4. We are putting the upper limit and the lower limit. A to the power 4 by 4, then 0. We are not writing that. A to the power 8 equals to, sorry, a to the power 4 by 4 minus a to the power 4 by 8. We have a to the power 4 by 8. So this is the answer for this question. I am ending this lecture here. Hope you have understood the topics I have covered in this lecture. I have just covered the basic topics of double integration and have done some of the sums here. And in the future lectures, I will provide you with more harder sums, more important sums, and more important topics of double integration. So do follow the channel, and thank you.